H-beam steel, also known as wide-flange I-beam, is a high-efficiency profile with an optimized cross-sectional area distribution and a more reasonable strength-to-weight ratio. Its name comes from the fact that its cross-section resembles the English letter H. It is widely used in steel structure buildings. Today, let's take a deep dive into the advantages and disadvantages of HBM steel. Let's start with the advantages first and foremost. In terms of structural performance, H-beam steel is far superior to ordinary I-beams. Due to its unique shape, the section modulus, moment of inertia, and corresponding strength of HBM steel are significantly better than those of ordinary I-beams with the same unit weight. This means that in construction projects, H-beam steel can bear greater loads while using less material, making it an ideal choice for building large-scale, high-strength structures. Another remarkable advantage is its high flexibility. H-beam steel has a wide range of specifications. The wide flanges and thin webs of HBM steel allow it to be used in a variety of construction scenarios, whether it is for the beams and columns in civil building steel structures or the load-bearing supports, pipe supports, transport bridge supports, and mine supports in industrial building steel structures. HBM steel can play its role effectively. In addition, when used in various truss structures, it can save 15% minus 20% of metal. The application scope of HBM steel is extremely wide. It is used in all kinds of civil and industrial building structures, providing a solid foundation for the construction of high-rise buildings, factories, and warehouses. Moreover, it is also used in foundation treatment and dam projects. In these large-scale infrastructure projects, the excellent performance of H-beam steel ensures the stability and safety of the entire project. It is also widely used in various machine components, contributing to the development of the machinery manufacturing industry. However, like any other building material, H-beam steel also has its disadvantages. One of the main drawbacks is related to the manufacturing process, especially for welded HBM steel. Welded HBM steel has relatively high metal consumption. During the welding process, a large amount of metal is used to ensure the connection between different parts, which increases the overall cost of the material. Another problem is the difficulty in ensuring uniform product performance. In the welding process, factors such as welding temperature, welding speed, and welding quality can all affect the performance of the final product. It is difficult to ensure that each part of the welded H-beam steel has the same performance, which may lead to potential safety hazards in some high-precision or high-stress applications. In addition, the size and specifications of welded H-beam steel are relatively limited. The welding process restricts the maximum and minimum sizes that can be produced. For some special construction projects that require non-standard or large-sized H-beam steel, it may be difficult to meet the requirements through the welding method. In conclusion, H-beam steel is a very important building material with many outstanding advantages. Its excellent structural performance, high flexibility, and wide application scope make it an indispensable part of modern construction and machinery manufacturing. However, its disadvantages, such as high metal consumption, non-uniform performance, and limited size specifications in the welding process, also need to be taken into account when choosing building materials. Engineers and designers need to comprehensively consider the specific requirements of the project, cost factors, and construction conditions to make the most appropriate choice. With the continuous development of technology, it is believed that the disadvantages of HBM steel will be gradually improved, and it will play a more important role in the future construction industry.